Welcome to episode 2 of the Unstable Fluid podcast. In today's episode, Kat and I discuss what it's like starting a PhD, how code is used in academia, and we introduce our first ever problem of the month. Enjoy. Hi, how are you, Kat?
Yeah, I'm good, Thomas. How are things with you? You've been doing a lot recently.
Yeah, things are good. Let's just go with full disclosure for the listeners. It's been 4 months since we recorded.
Yeah,
it's not quite 4. It's 3.5.
Okay, that's reasonable. I honestly can't remember when we filmed. Yeah.
I think by the time this podcast episode actually goes out, it will be just over 4 months to the day since we recorded the first one.
Okay, well things have happened since then.
A lot of things to catch up on. I started a PhD.
How's it going?
It's good. I'm no longer an unemployed astrophysicist.
No, but you are officially a member of a Welsh university. How does that feel?
I don't know what any of the signs say.
You picked up any Welsh?
Not really much more than I knew when I got to Wales, which was mostly from you, which being bore da, which doesn't apply because this is the afternoon.
Prynhawn da, nos da, noswaith da. Let's just cover all our bases. Good morning, good afternoon, good evening, good night.
Cool. I will definitely forget that.
Yeah. I'm half surprised you haven't tried impressing people in the club with Haven't
been to the club, have done that.
Nice. I'm proud. If I can teach everyone one thing, it's doing that.
Yeah, no, there's some folk on there's some other first year PhD students. They're actually from South Wales and they can't say it, so
hey, getting one up. Very nice.
Yeah. What have you been up to since we recorded the pilot 4 months ago?
I suppose the people that are listening to this won't see a drastic change, but hopefully the viewers will notice a mild difference of I changed my hair. I feel like this is not that big of a thing for everyone else, but for me this was a big deal.
It was a big deal. You got rid of the purple. Yeah,
I'm now off brand. I am now going for the autumn vibe of orange and brown split dye. I like it.
Or as Simon Clark put it, definitely not ClarkCon, chocolate orange hair.
Chocolate orange. I got pumpkin spice latte today, actually. That was the first time they were like this. I think more in aesthetic vibe than actual, it looks like a coffee. But yeah.
I don't know. It's is pumpkin spice latte the vibe you're going for?
A little bit. Leading into autumn, it's my favorite time of year, and I've had purple hair for so long. I was just desperate for a change. So I went to my hairdresser and I was like, I want something different. And that was the only thing I'd said to them. And then walked out with this. It was a bold move and I'm very happy.
Okay. Hairdresser you've been to for a long time or somebody new and they just were like, I'm going to do this?
No, I think I've been seeing my hairdresser for 10 years nearly. So
okay, right.
I trust
somebody
them a lot.
Does know you then.
Yes.
Okay.
Yeah. They were the one that first put the purple in. So.
All right.
Yeah.
Okay.
But yeah.
And aside from hair, anything new in the rest of your life?
I mean, there's going to be a very small subset of our listeners that care a lot about the hair story, and I feel like I'm not saving our entire audience, but for them, thank you for validating this. Aside from that, I have been to 2 continents. And 5 talks and or conferences. So the era of Kat puts her name out there to try and get a job has officially begun. I viewed this as the last opportunity to go as a PhD student to all of these talks and conferences. And also, just went
and use up the travel budget.
Yeah, I didn't want to say, but you run. They don't let you keep spending it. You've got a travel budget,
you might as well use it.
Exactly. So kind of definitely used up the rest of that now. I have one more trip planned as a PhD student, which I leave. Do I say I leave on Sunday? Because that's gonna dox the fact that this is gonna be go out weeks after the fact of recording.
I mean, it's a podcast. It's kind of a given fact. It goes out weeks after the fact. Essentially, you're saying you go in 3 days, right?
Yes.
Okay.
So finish recording this, go pack, maybe check that my travel is still available. It'll be fine.
Okay. Yeah, great. That's continent number 3, right?
Yes. Yeah. Fourth one over the last 12 months. Third one of this year.
You've not got that many continents left.
I know. I'm going to try and see if I can hit them all in my lifetime. It's going to be great.
Okay. I thought you were going to say the 12-month period. I think Simon may have a heart attack if you tried that.
Yes, yeah. I don't think that's good. Unless we do like an around the world via train type deal, I think that is pushing the boat a little bit too far.
Yeah. I'm not entirely sure you can take a train from Europe to North America.
No. You could do it by boat, though, in theory.
Yeah.
And if you went northeast, south, if you went east...
Yeah,
then
I suppose if you went
the
shorter bit over the top of the Pacific.
Yeah.
Yeah.
You just have to like detour down to Australia and back.
Yeah. Anyway, not that we're planning that.
No, but that
PhD
would
budget
be
definitely doesn't stretch to that.
An interesting problem to consider in the future, though, of just what's the optimal route around the UK, around the world. If you wanted to hit every continent and you really didn't like boats.
Anyway, yeah, we launched a podcast last episode.
We did. I suppose that kind of comes part and parcel of what's happened since we filmed the previous one. We put the first one out there, but yeah, it's weird. We're seeing it on Spotify for me. I think I saw it on the podcast app, and that was cute. And like on YouTube, that was also like, yeah. I don't know where people are watching this or listening to this, but it was Spotify that I felt like, oh god, this is real. Like that was new and shiny, and like I saw our podcast next to like actual professional podcast stuff. Like that was fun.
Yeah, Spotify definitely made it feel real. I think because I associate Spotify with people that actually do stuff as a job. Like you stream stuff on Spotify, and it's like, if you stream music on Spotify, it's all predominantly artists that do it as their job. And I don't know, it just feels more professional.
Yeah, it definitely does.
But yes, that was kind of fun.
Yeah, if you haven't listened to the pilot episode, go listen to that one and then come back. That's your homework.
Cool. Shall we launch into some of the topics we're going to discuss today? I feel like I'm gonna go to something that now that I'm officially no longer unemployed, I am back to student status, because apparently I'm better off without an employment contract, if you ask the UKRI. Starting out on a PhD, possibly. Yeah. So I suppose I had the terrifying realization that I just experienced my 9th freshers. Okay.
So I am quite far away from starting a PhD, unless I decide to go round again. But how has induction week, and I suppose everything you've been going through, like moving, how is it going? How did you feel?
I think I've kind of had the whirlwind of just about all the emotions. Everything from like excitement through to stress through to like, I can't really describe that emotion, but you know what I mean.
Existential dread? Slightly more happy than that.
Trying to deal with some of Cardiff's drivers, existential dread.
I mean, doesn't Cardiff have quite a good number of cycle lanes, or is this...
Yeah, that's the thing. Most of my commute is on cycle lanes.
Oh, God.
Yeah.
Oh, no.
Otherwise, it's fine. But yeah, it's that's the existential dread. The moving was good. Like I've moved down with my partner. So we've like moved into a house. It's like not student accommodation, which is really nice. Compared to rent prices in St Andrews, Cardiff is really cheap, which also helps. And yeah, the move though was a bit much. But yeah, trying to move down when you have to move on a Friday, because you've got like a family commitment on the Thursday, and then you're taking photographs for Simon SciComm-Con on the Sunday. That was a big weekend. Don't use the real
title. That's not. Yeah, that's not what it was called.
It's definitely not ClarkCon. But yeah, like that was a very full-on weekend, and then it also happened to be a heat wave.
Jeez, so that was quite intense.
Building IKEA furniture in the heat wave was fun.
I can imagine.
But yeah, had a bit of time to settle in, and then got started like induction into PhD through CDT induction, department induction, and then actually getting started and dealing with, all the IT.
Okay, so you said that you had CDT training and PhD training, or induction. What does that mean?
Essentially, it comes down to the funding. So it's a bit different from a standard PhD. Normal PhDs are funded either by yourself, being self-funded, or you're funded by like a research council. So for astronomy, it's typically the Science and Technologies Facilities Council if you're in the UK. But there are other funding pots. Some are like put together by like individuals who just bequeath a load of money to the university, and others are what are called CDTs, Centres for Doctoral Training, and that's what mine is. So I'm part of a CDT called AIMLAC, which is AI, Machine Learning and Advanced Computing, and it's a CDT split over like 5 different universities: Cardiff, Swansea, Bangor, Aberystwyth and Bristol. And it's multidisciplinary, so it's not just all astrophysicists, it's not even just all physicists. You've got mathematicians, computer scientists, biologists, a variety of different disciplines that all use either like big data or are going to be using machine learning techniques, AI techniques and all that sort of stuff in their research. So I had like 3 days of induction with them, because they give you a bit more sort of extra training, and over the rest of my first year I'm going to have like another 4 training events that are focused on teaching me how to use machine learning for one thing, but just other sort of additional training that people funded by, say, STFC won't get.
I see. That's very cool. Is there any extra assessment with your CDT then? Or is it just the training aspect?
Well, so there are some top modules that I have to do. It's not like, they're not like assessed really. Whether you get to progress is based entirely on engagement. So as long as you engage with the module, then you're fine. As long as they can see like you're not just sitting around doing nothing. So like I have a data analysis module that's hosted by Cardiff Uni. The amount of engagement I have to do with that is there is like a small continuously assessed thing at the end of the module, and it's like as long as you do it and you have like clearly put in the effort to learn the stuff and do it, then that counts as you've engaged sufficiently with that module. And then there's another module hosted by each of the host universities.
Okay, so that's really cool. Yeah, so my CDT has a training component, but it has a first year that is a master's year. So they package the training as like, if you're going to do all this extra work, we may as well try and get you a qualification out of it. But you have to be like well-rounded in the stuff that Samba offers. But interestingly, so they're in the process of putting in a new bid for funding for the CDT. The new one is potentially not going to have that master's year, because there are pros and cons in that I now have 2 master's degrees, which is quite fun. But fundamentally, it's all just training for the PhD. So spending more time developing the skills for the PhD might be a better use of time. There's no right or wrong answer, but it is interesting that different CDTs do things differently.
Yeah, mine is like actually quite different. So as part of the CDT, between your sort of second and third years, sort of over that interface between your second and third years, you take 6 months out and go and do a 6-month placement in industry with a firm that works with one of the sort of areas associated with CDT.
Yeah.
And it's something that isn't the PhD going to be like similar sort of work to what you're doing. So we don't have the master's year thing. We have this separate go into industry and be somewhat useful.
That's quite fun. And then you learn all of the industrial skills, I imagine. You say that like, because you do big data, but you do space.
Yes.
So are there companies that do spacey big data? Is that a thing that exists?
So astrophysics research is almost entirely limited to the world of academia.
Okay.
Like, so most of it's done in universities, and then there is amounts of it are done by sort of governmental organizations, things like NASA and the European Space Agency and their counterparts in other places around the world. They will deal with sort of astrophysical research as well. Like the amount of data that comes in from the likes of JWST and Hubble and all that sort of stuff that comes in through the Space Telescope Science Institute, I think is what it's called, and then gets like processed in loads of places around the world. But most astrophysics research is done by people who are fundamentally publicly funded.
That's fair.
So doing big data things in what I do in astronomy, I would end up doing probably big data things in another area that is not astronomy.
Okay.
In my placement.
You said you're doing modules in other places, like in the other institutions. Do you?
Well, I will be.
Yes. Sorry, you will be.
I have not been given access to the ones I should be doing at the minute.
Oh.
University bureaucracy moves slowly.
Yes. Yeah, it does. Something that I remember in my first year took an absolute age. Have you been paid yet?
Tomorrow.
Okay. That's late.
Yeah.
Yeah. The
essentially the problem that they have in with like Cardiff paying the stipends for new starters is like the way the policy works, they can't get our bank details unless it goes through a Microsoft form that only people with Cardiff University email addresses can access, and we don't get access to our emails until about 3 weeks before we start.
Yeah.
Which is then not enough time for them to apparently process payments out on the 1st of October.
I see.
So
I
yeah,
think that's
I have had the email. I am getting paid tomorrow, allegedly.
exciting. Drinks are on you then.
Yeah.
No, it's something I
Rent is
remember
on me.
when I started was you needed to be registered and like proof that you have like right to work and that your funding's like everything's all checked out and you are who you say you are. But you do that when you get there. But by the time you get there, you've missed the... so if you are funded in the UK, the stipends come out quarterly. So everyone's just there like desperate for the 1st of October because that's payday.
No, I know what you mean. It's people that have just come from undergraduate master's degrees, so integrated masters where you do it all as a oneer. Like, the student loans stop in like June. You have 4 months with no income, and then you work for half a month before you get any money from your stipend.
Yeah, the funding opportunities are good in some ways and absolutely awful in most of them. It's one of those things where it's very difficult because I think fundamentally, as long as everyone is going into it with their eyes open of this is what it is, this is what you're being offered, and these are your options that are available, like that's the thing you want to focus on. But then at the same time, making sure that, well, there are things that definitely can be improved. So can we get on that, please? Yeah, just because you're aware of all the issues doesn't mean that you can't still want to improve your environment.
Yeah. It's that sort of thing. Like, being aware of all the issues is, I think, like, yeah, if it was being hidden from people before they start, that would be a bigger problem. If
you want me to start ranting about things that aren't told from the get-go, I am very close to running out of funding.
I was about to say that, yeah, there are many things that they don't tell you when you go into a PhD.
Yes.
And, like, do you want to elaborate? Do you want to rant?
I kind of do.
Do I tint the whole screen red at this point?
I am very fortunate. So I have had this stress for a very long time. And actually, as I was saying, I think before we started streaming, I have just come from a reintroduction where my director of studies sat down with all of us final year or post-final year or pre-final year students and later half PhD students.
Order of magnitude final year students.
Yes. To be like, hey, this is all the information that we did throw at you in induction week, but you don't really remember because you were overwhelmed and focusing on the immediate stuff. And we're actually going to like take an hour, have a full conversation about it. And we were asking every question possible. But basically, there are 3 deadlines that are important when it comes to the end of your PhD. And I have recently learned that it is different at every institution. So when you're applying for something, if this is something that is important to you, make sure you ask. Again, I can't tell you, Thomas, but check with Cardiff. But there's typically a registration deadline, which is when the university stops considering you a student. There's your funding deadline, which is when they stop paying you. And then there's your submission deadline. And that's like when you need to get the thesis in by. And typically the thesis, you have to get your thesis in by the end of your registration because otherwise you're not a student anymore. But you run out of funding sometimes anywhere up to a year before that. And they just stop paying you. And at that point, the university turn around and they say all of these fees that have been covered as part of your stipend. So not only do you they pay our stipend, they pay for the tuition as well. They turn around and they say, well, you owe us this now. You actually have to start paying the university.
Even though they no longer consider you a student?
No, so this is before they stop considering you a student. So they stop paying you. And then for me, I have a year of, I'm still a student, but I'm not being paid. So I have to start paying them tuition. And that is, that's quite common.
Even if you're in writing up status.
So this is the get around, and this is something that I'm looking into at the minute. If you do nothing, you run out of money on the 1st of January or the 1st of April or the 1st of July.
Probably
or
1st of October.
1st of October is typical, yeah. I'm actually end of January because I have 4 months since, anyway. You run out of funding. And then the next day, you get a very angry email from your university student finance saying pay tuition fees, which can be anywhere from like the order of 500 quid for a year to like thousands of pounds for a year, depending on your home or international status or how long they're expecting you to pay up front. And yeah, if you don't do anything, you get that email and that's it. You have to pay them. Luckily, most... And again, this is apparently not standard, which is something that I thought it was, but most places will let you go into writing up status, where you make an agreement with the university that you're going to stop doing research and spend more time on writing. Some to most universities will then eat the cost of the tuition if you write this agreement with them. But you have to give them this big plan of like, no, I promise I'm writing up, I'm doing these chapters in this time, and you have to give them this like proper detailed skeleton of the plan. And that will buy you maybe 6 months. You know, things come up, life happens, it gets shifted. And if having the extra time is something that works for you in your life, then that's great. I'm going to go into it. And I don't think I've spent a lot of time over the last few months kind of coming to terms with the fact that I have come into terms with the fact that I almost feel like a failure because of it. And that's not okay. Because actually it is really common, and it's not a comment on my lack of ability. It's a comment on like just where the research is, and I'm fortunate that I can. But
yeah, it's definitely not a comment on you. It's a comment on the system as a whole. The idea that this sort of stuff isn't necessarily told early on, so people don't have ample opportunity to plan for it. Like if you're told at the start of your PhD, it's very common for people to go into like a 6-month writing up status or maybe not even writing up status, but it's very common for people to
overrun,
not quite be finished when their funding runs out. At this point, the university will charge you. Then people can start thinking, okay, well, 4 years from now, I'm going to have a bill of £2,000. Well, in that case, I've got to put away 50 quid a month.
Yeah.
If I can, to prepare for that bill that will come if I'm not finished in time. And if you've got 4 years to plan for that, that's somewhat more manageable.
I think as well, it's being aware of it so that you can have that conversation with your supervisor. Like, I was very fortunate that I have a really good relationship with my supervisor, and we have been on the same page about my finishing date for the last year. But I think if you're not aware of it, and then suddenly you're being told that you're expected to pay some like amount of money in 6 months' time, it's a lot harder to kind of stand up to your supervisor and ask for the accommodation of like, no, I need to know that we're on the same page about when I'm finishing. Or what can we do to get us to the point where I can finish on time? Especially if you're thinking of not staying in academia, which is a very, very common route through a PhD. Like, you don't have to want to stay in academia just to do a PhD. You can do it for personal reasons, for development reasons, for training reasons, for just
personal curiosity.
Yeah.
I mean, you've got that whole thing of there's like order of magnitude fewer PhD places than there are undergraduate places, and then there's fewer postdoc places than PhD students, and fewer like positions to become like lecturers or readers or whatever, research fellows and such. Like, you sort of funnel down. There's like it's not a pyramid scheme, but the hierarchy is a pyramid. But I don't know, academia may be a pyramid scheme. That is also a quote from somebody in my department.
I mean, I fully back it, and I've heard it at many conferences. But no, it's if you know that you want to leave and you want to get a job, or if you have a job lined up, you need to finish. You can't work two full-time jobs, but for a lot of people, what ends up happening...
Some people have to.
Yeah. A lot of people do it, or they spend some amount of time with nothing.
I feel like coming into the PhD, there's a lot of things in academia that people take for granted that you just don't know. Like everyone has collaborators. And it's like, how do you get collaborators? My mind's gone blank on all of the other possible examples, but there's a lot of things in academia they don't really tell you. Like, I don't know, like, how do you decide something's worth writing a paper on? How do you come up with new ideas other than just like be told by your supervisor initially, do this, but you're meant to evolve into this person that can come up with something new?
Yeah, I mean, if you figure out the answers to these, can you let me know? Because I'm still...
The collaborators thing is the thing I really don't understand. Like, how do you suddenly decide, like, I'm going to write a paper with this person?
So I think a lot of it is networking. I think actually the answer to a lot of this is networking. But yeah, like working with people in the same way that any sort of connection or interaction happens. Like you could say, okay, say you don't know how to get collaborators, but arguably we're collaborators, but just for science communication.
Yeah,
and that's because we started talking at something, say on Simon's Twitch, or I don't really remember how I met you. It just appeared one day.
Yeah, it's surprising how often that happens.
Yeah, and I think that's actually quite common in academia as well, of say you go to a talk or you go to a conference or you're just standing in the dinner queue next to someone and you start chatting. And if you're in the similar field, you talk more about your research and then it kind of develops from there. Or you've been introduced by someone. So I have a collaborator, just the one, but they're lovely and I really like them. And that came about because my supervisor was like, the stuff you're doing could be really complemented by their work. Let's have a meeting with the three of us. And it kind of developed from there. And now I have a really good working relationship with them and their research group. And I'm slowly like building up those independent connections with people that they've introduced me to. And I think a lot of it is just knowing, I'm going to say the right people, but by that I mean people who don't want to pick the ladder up behind them. Yeah, if you can, as you like progress to a more senior position, and they'll happen sooner than you think, because people now think I'm senior and I'm like, that's not, stop it. Only within the PhD sphere, but still, yeah, making sure that you help out other people along the way as well. So
yeah, that's good.
But yeah, it's then when you do have those chances of like, say before registration or during lunch or just in passing, getting to know people. But the thing that I'm very bad at emails. Anyone that's tried to work with me will know I'm very, very bad at communicating. But something that makes me really happy. I do my best. We can have an entire conversation about like imposter syndrome and anxiety around academia.
Oh, we will at some point in a future episode of the podcast.
Yeah.
Like, subscribe on YouTube or whatever the subscribe option is on
follow
podcast apps. I don't know what it is. I don't actually use podcast apps that often.
I think it's follow. I don't know.
I think it's probably follow.
Yeah. But anyway, I'm really bad at emails, but it's ironic because I've had a few people do it to me and it has always made me very happy. Of after I've given a talk, someone has sent me an email saying that they enjoyed. And like even that interaction of like, didn't get the chance to talk to you, but really, really enjoyed your thing, or like didn't get a chance to talk, just wanted to ask a quick follow-up. It doesn't have to initiate a full conversation, but just that awareness of people. It's nice to give feedback. If you're going to email someone and say your talk was awful, don't do that. But
yeah,
if
rule one of the internet also extends to real life. Don't be a dick.
It's surprising, but yeah, that has always made me really happy, and starting those conversations I think is a nice way to do the networking without, if you do have life outside of things. I highly recommend, because genuinely I had someone email me yesterday after a talk I gave and were like, it was really nice to meet you and I really liked what you did. And I was sat there grinning for about half an hour because it made my day.
I had like a similar experience after we launched the first episode of the podcast, and somebody just sent us a really nice message on Instagram.
Oh yeah. Yeah, if you like this, tell us, please. Please.
Yeah. Somebody sent us a real nice message on Instagram. I can't remember who it was. But yeah, the message was really nice, and I just like immediately screenshot it and sent it to you, and I'm like, we got a really nice message. Somebody actually liked the thing.
Yeah.
And it felt really good. So yeah, like Kat said, like if you like the thing, tell us. We've gone sort of uphill on from where we started on things they don't tell you about academia. So shall we leave that topic on a bit of a high note and talk a little bit more about doing research in the sciences, which more often than not now involves coding?
I think we should. I enjoy that you're like, right, we're on a high, let's ruin it with Kat's talk about MATLAB. But yes, yeah. It's something that even the pure mathematicians that I hang out with who like historically do not touch computers are starting to do some sort of coding, even just for visualization purposes. I would consider myself a numerical fluid dynamicist, but that's like very soft computing in the grand scheme of like if I think of someone who is a computer scientist.
Yeah.
I'm still quite small models in comparison to that, but in comparison to someone in pure maths, I'm the computer whiz.
No, I suppose like before we go any further, we should like quantify what we mean when we say like coding in academia. So this is going to be anything involving writing computer code to do anything involving research. So that can be anything from like doing data analysis to doing sort of more, is yours analytic, semi-analytic?
Yeah.
Just try and model those sorts of models, right?
Yeah, I mean, like I would say the analytical stuff is the maths, and then the numerics is the numerics. But
anyways, yeah, okay. So going from sort of everything from doing data science, doing statistics and computers using things like programming languages designed for that, all the way through to, at least within what I mean when saying like using it for science, you can go into like big simulation side. So the sorts of things that I will be working on, where you're dealing with simulations generating terabytes of data, where you're having to do complicated things in the computer because your RAM isn't big enough. And then you also have people doing sort of things that fall more under computer science, where you can have people developing machine learning, where you're creating programs that improve themselves through taking in training data, or developing other programs to do things. So computing in academia is very, very broad. I
think a lot of the side of it that I see on the mathsy side is there's definitely a larger and increasing subset of machine learning, especially collaborations with industry. I think machine learning is quite a bit of a buzzword and a lot of people really like it. And I also don't think it's going anywhere. So it's good to at the very least have some idea of it. Machine learning is definitely not going anywhere because it can just do so much more than we can do with traditional like statistical techniques and such. Yeah.
To be clear, when we're saying machine learning, we're talking about the type of program that can improve itself based on input data, not necessarily something like ChatGPT.
I suppose this is where it starts going dangerously far away from what I know, and I have to try and remember the many talks and machine learning modules that I did way back when. But ChatGPT is more AI, right? Like it will put words together. It's not writing something, it's putting words together in an order that is probably very high to matching what the answer is actually going to be.
So it's made a load of connections based on its input data, and when you ask it a question like give me a clickbaity title for a YouTube video about nuclear bombs or something like that, I don't know, we can come with a better example.
It will tell you to stop asking it about bombs, I think, if you do that.
Yes, I think probably.
I mean, something that I have a really good example for this one, actually.
Okay, go on.
If you ask it a maths question, if you tell it to solve, for example, someone did it as if you solve a quadratic equation, you give it a quadratic equation and you type it in and you say solve this equation. Especially if you say do it step by step, it will write you a big paragraph, and the words, if you skim it, the words match what a maths teacher would say or what I would say if you asked me to explain. But if you actually look at the equation that you get given, quite often it's wrong, especially if the numbers are big.
In fact, you've chosen like a quadratic equation example for this. In some cases, it's even worse than that for doing maths. If you ask it to sum two very large numbers, it will at some points get it wrong.
Yes.
Because it's not doing what computers normally do, which is add things together really well. Like if you give a computer two numbers and tell it add them, unless something's gone very, very wrong, it should get the right answer. But because of the way programs like ChatGPT work, it doesn't, because it's looking for connections between strings of text. It's not considering them necessarily predominantly as numbers.
Yeah, it sees what you've inputted, and it looks through, say, the entirety of the internet to try and find something similar, and then just matches to what it thinks the answer is without actually doing it's not a calculator.
No.
But I've seen a few different people write little blog posts dotted around the maths internet sphere of this example, because I think up until that point I hadn't really grasped what it was. Yeah. Like, especially now, there are so many good maths tools on the internet. Like Wolfram Alpha is a website where I personally will put a lot of my problems in there and be like, can you please...
Well, it's essentially a web terminal for Mathematica.
Yeah, exactly. But it's actually doing the computation there. There's no AI, there's no machine learning, as far as I'm aware, beyond interpreting. Beyond interpreting.
I get what you mean, and we've very much diverted way down the idea of machine learning and such. But anyway, all of this stuff, veering right back to what we were trying to talk about, all of this stuff falls more under computer science than, I guess, using computing for science.
Yes.
Which is it's a subtle but important distinction.
I have a question for you.
Go on.
What is the difference between computer science and scientific computing?
I would say scientific computing is the use of code to do science. For example, like using it for data analysis or using it for simulations of a physical system, for example. Whereas computer science is more about the structures of programs, the structures of how a computer works and how you interface with it through code. I
think that's a fair comparison. I think scientific computing I always picture as the big heavy many terminals up and gonna hack the mainframe stuff with big code. And then computer science is like, can we make, if you have a code that does a certain task, can we understand how to make it faster, more efficient? Do we understand exactly what connections are happening there? I just plug things into MATLAB and try and make pretty pictures.
Also, we've talked about the breadth of things that people do with scientific computing in academia. You can't just do everything with Python.
Nope.
There is a variety of people using a variety of different programming languages that go from the highest level, you basically tell it do this thing and it essentially just does it, which is where I kind of put Python, where it's got so many extra functions and black boxes that you don't necessarily have to understand how they work to use them, all the way down to your low-level code languages where you're essentially telling the computer, this is how, I want you to add these two numbers together, then do this, and you very explicitly tell the computer what to do. In my undergrad, I have used both very high-level codes like Python and low-level codes like Fortran. I will be doing a similar thing in my PhD, doing a lot of data analysis in Python, but then the codes I'm running are again in a low-level language using C and C++. Kat, you use something else?
So, yeah, you said a lot of big scary words there.
Please do rein me in if I say too many big words.
I'll start being like, explain what that one is, but I think you covered everything. If listeners or viewers disagree, then, you know.
Tell us.
Yeah, DM Thomas.
DM the Unstable Fluid podcast Instagram.
Which is Thomas.
Which will be me.
I don't do anything useful beyond talk at Thomas for a few hours, and he deals with it. It's great. Anyway, I don't consider myself a computational person. So like computational fluid dynamics, CFD, is like kind of an established field within fluid dynamics as far as I can tell. And that is where all of the scientific computing people kind of live in the fluids, like academic landscape. That sounds like a fancy word. Let's go with that one. Yeah, so
I think
like
that works.
CFD, scientific computing, I think those are kind of sort of loosely interchangeable. And I say that with a grain of salt because I don't want people to come
within
for me.
The world of fluids, yes.
Yes. I would consider myself numerical, which I personally perceive as slightly below CFD. If you're talking about this big like pillar of from just making the computer run everything to only doing things with pen and paper, I kind of sit in the middle of I do some coding, but I've done a lot of pen and paper maths beforehand so that my code is quite gentle in comparison. Like, it's not really big. I'm not solving everything. I've made a lot of assumptions in my system to make the equations that I'm looking at much smaller.
Right. So you're taking a problem that has a load of different aspects to it on paper, condensing that down into like 1, 2, maybe 3 equations that capture all of the important physical phenomena, and then putting that into a much lighter weight program that can run on a laptop.
Yes, exactly. And I think that's a good indication of the sort of the fluid dynamics sphere as well, of like, you have the people that we all go from the same equations. We all start with the same thing of just like every single point in every single space is defined by the Navier-Stokes equation. Mm-hmm. A scientific computing aspect of fluids will take those equations, plug them into a massive computer, put your conditions and your physical parameters in, and just run and get back a load of stuff that's taken a long time to compute, but every single point and every single space, everything about it. Mm-hmm. That's that side. There are analytical people that look at the Navier-Stokes equations and then they take them so far away from reality that they have these cool, complex, what if there's a wave, but the wave is a perfect circle?
Okay.
This is definitely a conversation we can have in the future, but like, there are genuinely people that study these like vortices, so like this swirling pool of liquid sat as if it was a wave moving along the surface of the ocean, for example. Yeah. And it's like, that's not physical, but they know everything about it because they've done all of the analysis. But that's not something that is real. So it's that like very far away from understanding and like using a computer for it. And then there are those in the middle that kind of do a lot of analysis to make it nice and simple and then feed it back into a smaller program. My computing language is MATLAB. And MATLAB was kind of designed for mathematicians, but it's the thing that it's really, really good at is doing really big matrices and matrix multiplication. And that's just like big grids of numbers and multiplying those together. Like, that's the thing it's really fast at. That's what it was designed for. And because of that, it's really good at doing these like long lists of equations, because you can think of a set of equations as a matrix multiplication, basically. So yeah, like, it has its ups and downs. One of the major downsides of MATLAB is it's behind a paywall. So if you're not affiliated with a university, you typically can't get access, or a company, you can't get access to it. And that's really bad, especially in the world that we're trying to, public access is kind of important.
Yeah, and it also just creates like difficulties if you then move into doing something that's not with MATLAB. Like, if you've learned to code in MATLAB and then you go into a workplace, like, oh yeah, we use Python for everything.
Yeah.
If you've never used Python before, that puts you at a massive disadvantage. And you could argue the same going the other way, but fundamentally something like Python is free.
Yes. Yeah, and you can always kind of adapt to it. Yeah, that is a bad thing. However, my justification, and when people inevitably come for me for this, the justification I will continue to use is it has been used by fluid dynamicists in the UK in maths for decades. And fundamentally, I would love to sit down and just rewrite all my code in Python. I'm sure it would make my life a lot easier sometimes if I did that. But all of the packages that exist, all of the resources that exist, and all of the support that I can ask for will be in MATLAB. So my supervisor does not do anything that isn't MATLAB. So I'm struggling with my code or I'm struggling with my maths, and he can help with both at the minute. If I switch to a different language, he can't help anymore.
And I totally get that. And as much as like they have the whole argument about a paywall, you can have the same argument about coding languages that are just older. Like in my undergrad, I was taught how to code in Fortran 90 in a computational astrophysics module. Fortran 90 is, as the name suggests, is from 1990. And we're still taught it in the computational astro course at St Andrews because there are still a lot of tools, either legacy tools that have been written in Fortran that we need to use in a lot of like the research projects, or because there are tools still being developed in it. Like in my master's project, I used an astrophysical fluids code. So it can do a lot of fluids things, but it's designed for doing astrophysical fluid stuff. And that's written in Fortran 90, and it's like being actively developed at the minute. I can go into the Slack channel and I can see the commits that have gone up in the last week. Yes, it's not a modern programming language, and people will question like why I have used it, why I like it. But fundamentally, it's kind of the same thing, that if I wanted help in my master's project, well, I needed to know how to use Fortran to use the tool in the first place. But if I was like, okay, I'm gonna like basically try and redo this in C, for example, I wouldn't be able to get help with it. And it's exactly the same thing. It's just replace paywall with old.
Fortran 90 is old. It's an old coding language. It's not that much
10 years older than me.
I was going to say, it's not that much older than me, but it's younger than some people we know.
Yeah.
But in terms of how quickly just the computing world has progressed, like if you think about the amount of technology, like one of the iconic things is like you can tell a Gen Z because they don't remember cassette tapes. If you think about how quickly technology has advanced in the last like 30, 50 years.
Well, I suppose if you think about the fact that there are now people who are reaching the age that they'll be doing like GCSEs or in Scotland National 5s, and they've been born since the iPhone. Like the iPhone existed before these kids did.
Yeah, that's bonkers. Oh, thank you for making me feel old, Thomas.
I'm getting to the point that there's like folks starting university who were born after I went to primary school, and that was wild.
It only gets worse, I promise.
I know it only gets worse.
Beyond just causing existential dread and losing all of our listeners that are over the age of 30 because we're being old and jaded in mid-20s.
Yeah, I'm not even sure I'm in mid-20s yet.
Oh, I hate you.
I don't know, it depends what you class 23 as. I think it's just the year everyone hates you.
Early to mid, in the same way that 27 is definitely mid to late, not late, because I don't want to be late 20s. The point I was trying to make was that technology has advanced so quickly, and typically research moves really slowly. Like, I am reading papers from the 70s that are considered modern. Like, academia does move on a different timescale, and when you then combine academia, which is quite slow moving, with something like technology, which is really fast moving, it's no wonder that it's taken a while to kind of catch up.
Yeah, I think it definitely depends on your field though.
Yes, yeah, definitely.
Because you're saying like there's papers from the 70s that are considered modern. Papers from the 70s in astronomy are some of the earliest papers in like the astronomy backlog. Because astronomy is fundamentally a science that has developed in time with technology. Like up until the development of cameras, the biggest detector that humanity had for astronomy was the human eye. And then we got to having like photographic plates, and we could get much bigger, but they weren't particularly sensitive, they weren't the most accurate things. And then we got to film, which you could start doing a bit more, and then we got to like CCDs, the camera technology we use now, the sort of semiconductor based things that are in your phone. And these keep getting better and better, and the amount of astronomy that's been possible to do since the invention of CCDs and the invention of microprocessors, astronomy has accelerated so much more because of technology.
I see.
Whereas people have been able to do math with pen and paper, well, quill and paper for centuries.
I was going to say, like, there's a book that I have somewhere on my desk that is one of the big boys that I cite and that I use a lot. And that was written in 1890s. I think the edition I have is from 1918. Even that is not the oldest thing that I regularly have to like refer to. But yeah, maths has been around for a while.
I mean, astronomy has been around for a while. I mean, astronomy is arguably one of the oldest sciences. Like, realistically, ancient Greece had people like looking up at the sky and thinking, that thing's changed, and writing it down.
Can we do an episode on old school astronomy? Because I vibe heavily with the geocentric model. Please. Like,
I have so many questions and they do not fit in this episode.
But like, just as an aside, like, do you ever think about how freaking cool it would be, but also how like it's such an interesting perspective into like the human brain that we looked up and went like, there are loads of disks around the Earth, because obviously that's the thing that makes sense. Like, it's cool.
Okay, right. So like the really early geocentric model, not the mathematically batshit crazy version.
Oh, I mean, I like the fact that Venus does a pentagram in the batshit one as well. But like, can we please do like a history of astro?
We could do a history
episode
of astronomy episode at some point.
Yeah.
Okay, so moving on from apparently the geocentric model is a good idea to talk about, jumping way back to when you were talking about the different types of using computers for science and having everything from like pen and paper, if you're mathematicians that basically don't really use it that much, to where you sit, where you sort of funnel it down and then have a lightweight program. And then you have the other end of the scale, the very big simulation type codes, where we take all of the physical laws and just run it until it cries. Yeah, I land at that end where we take a load of different physical processes and let them evolve, because our systems are so complicated that it is not, it is a near impossible task to try and distill them down into a set of nice analytic equations. I'm studying galaxies, and if we're dealing with, you've got also the fluid flows that you're trying to keep track of. So where is the gas? Where are the stars? Yes, we model stars as fluids. Then alongside that, you've got to deal with temperature and metallicity, which is all the stuff that isn't hydrogen and helium, and how that goes where, and then keeping track of temperature and how that all interacts with each other. And that's only a few of the parameters that we have to be modeling in these large scale simulations where we're trying to reproduce what actually happens in the universe. And that's what gives us the terabytes of data that make, computers really struggle, and we have to get really creative about loading things into RAM and then out of RAM. Otherwise, it's like, so why does this computer not want me to load 50 terabytes into RAM? Oh, right, it's only got 4.
Sometimes I think I have big code, and then I think about like, I made like a whole gigabyte of data from one of my simulations. I'm like, that's loads, it's so big. Nah. Probably like going straight off tangent again.
It's fine.
Is there no like analytical models that you could use? Because if you're doing fluid dynamics for space, like must be some stuff, or is it just not good on the scales that you're playing with?
So we do use some analytic or semi-analytic prescriptions for different phenomena. But fundamentally, the reason we use them is because they're prescriptions for processes that happen beneath the resolution of our simulations. My simulations are looking at a thing called the circumgalactic medium, which is essentially a puffy gaseous thing in the around a galaxy that extends to like 300 kiloparsecs from the center of the galaxy. A parsec is about 3 light years, 300,000 of those, so like nearly 1 million light years. These simulations are huge, and in the best case scenario, which is incredibly computationally intensive, our simulations get down to a resolution of about 250 parsecs, which is about 750 light years. The distance between Earth and the next star over is about 3 to 4 light years, I think. So
okay.
We're not even able to resolve like molecular clouds that stars form from when we're doing these simulations. So these gigantic clouds of gas and dust that collapse down to form stars would all fall within one grid cell of our simulations.
So what are you looking at on that sort of a scale then?
So on that sort of scale, we're looking at basically bulk gas flows and how... so we're interested in what's happening in that halo. So we're looking at how gas is moving out of the disk, being driven by gas accreting onto a black hole, and we have like basically models informed by higher resolution simulations that say, right, at this time in a galaxy's evolution with this amount of gas in the galaxy, this galaxy should be creating X amount of stars, and we have like a star formation history model, which is what we call a subgrid model, that basically says the star formation rate in this area is this. It's producing this amount of stars, which then produces this effect on the gas in the cells nearby. We have like semi-analytic or analytic prescriptions of phenomena that we can't numerically resolve. And this is one of the biggest issues we have in doing simulations like this, is that we can't do it perfectly. Like, in an ideal world, yes, we could keep track of every atom of hydrogen in a galaxy, but that is a completely impractical simulation that would never finish.
That's kind of interesting that, like, I guess we would call it like a multi-scale model of, like, you have something on the or like a hybrid model, I think this one of my friends does with on a much smaller scale, but you have like microscopic, macroscopic, and then trying to match or inform the small scale to the big scale stuff.
Yeah, so like
that's very cool.
One of the things in galaxy simulations is there's a thing called the interstellar medium, which is all the gas and everything else between stars, which is like a really important part of a galaxy, and everything that happens in it happens below our resolution. So there are people that are people whose like research area is running higher resolution simulations of the ISM to try and create better subgrid models to feed into large galaxy simulations to try and make our simulations more realistic.
When your research is kind of almost neck and neck with the ability of technology, that's a really interesting
astronomy
thing that
almost always has been.
Yeah, I wouldn't have even like crossed my brain of something to consider. Like within my stuff. I enjoy that not only do I do small scale fluids and you do big scale fluids, but within those fields, I do the small scale model and you do the big scale model.
Yeah.
So when you're talking about these submodels that feed into bigger stuff, like because I'm looking at one bounce of one drop with one small, like understanding the air layer, that feeds into droplet behavior as like a slightly bigger field. So I think that's a really cute parallel, actually.
I think the only thing we haven't really talked about, though, when we've been discussing coding in academia, is how it's taught by universities to undergrads. And I have a feeling that you're going to have thoughts, because I also have thoughts.
Okay, so my thoughts are split in that I was taught by a very good lecturer. And to the point where I actually, in my final year of undergrad, tutored that module, or like I did the labs for that module. But I was taught in Python.
Yeah.
This is instantly something that I am more comfortable moving around coding languages than I need to be, because I was taught in Python and I've done all my projects in MATLAB.
I'm in a very similar situation. I was taught a variety of programming languages, like my undergrad maths modules taught me Python, then physics taught me Mathematica of all things, but then also Fortran. So yeah, similar scenario of being able to jump between them. Yeah,
and I think actually if you have that experience, especially really early on in learning how to code, can be really good. Not everyone needs to know absolutely everything about coding.
Yeah.
And, you know, you can sit there and be like, what's the point of learning Pythagoras in GCSE maths? And the answer is arguably nothing. You're never going to use it. You're right. Good job. Proud of you. The point of doing it is to develop the skills and the critical thinking so that when your problems are thrown at you of a similar sort, your brain already has that pattern recognition in, or you know how to handle something you haven't seen before.
I think an even better analogy for the advantages of learning a bit of multiple programming languages earlier on in your coding journey, I think better analogy is like kids that are introduced to multiple languages, like spoken languages. Like if you grow up in, I don't know, Canada and you have to be bilingual English and French, or you grow up in Wales and you have to be bilingual English and Welsh, or some other country where English isn't one of them. Like if you learn more than one language as a child, it's much easier to learn additional subsequent languages further on, because there's like, it's more subconscious, I get, with like spoken languages, you have more ease switching between them. But if, say, I was only taught Python from like the first day I showed up at university to the last day I left, I think I would find it incredibly difficult to now go and learn Fortran, because everything that I'd ever learned for coding would have been within that structure of Python, which kind of holds your hand through a lot of it and doesn't teach the best coding practices, but that's a separate issue. I feel like the spoken language analogy is a good one. It's a pretty good analogy for coding languages. I
completely agree. Yes, so with the language analogy, I think it is fantastic and you'd have to talk to a psychologist to get like professional answer on this, but I think it's something about like the pathways already being in place that separate the language from the kind of concepts that you're trying to convey. And if you understand the concepts, you can interpret them in the right way. If you can learn lots of coding languages, or if you learn multiple languages, you learn the grammar of that system more than you learn the actual words. So then when you need to use a different word, you already kind of understand what you're trying to convey, and you already have like a bit of a head start. I think it's the intelligent version. There's a succinct version of that out there somewhere in my brain.
Shall we move on from coding in academia? I feel like we've gone on about this for a very long time. Like we said last time, this podcast is going to evolve as we figure out what it is we want to do with it. And one of the things we're going to bring in is, I'm going to call it Problem of the Month. This podcast may not come out every month, but we're going to call it Problem of the Month. So the problem I'm going to suggest we think about is, how would you go about calculating a temperature for the Earth?
Okay, and I'm going to be a fussy mathematician and say your problem is ill-posed. What do you mean by temperature of the Earth?
That is a very good question to pose. Okay, because the Earth has so many different temperatures you could measure. You've got like land surface temperature, which obviously varies across the globe, because you've got, everything from the Sahara Desert, or the desert, to like Canada.
Yeah, or Torpenhow Hill.
In winter. Hill, yes. And that's just land temperature. You've then obviously got ocean temperature. You've got the dayside versus nightside. You've got, you can talk about temperature X distance below the surface of the Earth. You get X distance above the center of the Earth, if you consider it above the surface of the Earth, if you're considering the atmosphere. I guess where I was going with this question was considering, I guess, average surface temperature, and taking surface temperature to be land. Okay. So the average land temperature of the Earth for a given time.
Okay. It's an interesting problem, because it's like, okay, it depends how much time I have to do it, or like, say, you want it at a single point in time. So let's say, how many resources do you have available? Because if you have infinite resources, I'm going to stick a thermometer a meter grid apart all over the surface of the Earth, and then take all those readings and average them. Yeah,
that is certainly a very empirical way you could do it. In an ideal world, that would be how you would calculate the average surface temperature of the Earth.
Yep. And in my infinite infinite resource plan, that's what I'm going to do. Because you didn't specify. No. But say I didn't have infinite money or infinite thermometers, or finite but large number of thermometers. How would I go about doing it then? What's your idea?
I would go about it from a very physical point of view. I guess I would think about it as an input-output problem, because the Earth is a physical system. It receives energy and it emits energy. So primarily it receives energy from the sun, and it will emit energy from its surface through radiation of heat. So the simplest way to do it would be how much energy is coming in, and then measure how much is being given out. Now, measuring how much is being given out is difficult. You can consider how much is being reflected, and then you add in the complexity of the atmosphere. And the fact that it's a complex fluid system consisting of a variety of different molecules and different physical structures, like how much CO2 is in the atmosphere currently versus how much is it going to be in the atmosphere in 5 minutes, because fossil fuels. But I think, taking into account all of these, so like, I guess if I wanted to have like a very crude model of it, the main things I would want to consider is how much energy is being brought into the system, how much is being reflected by the Earth, because not everything will be absorbed, how much energy is is being emitted by the surface of the Earth at a given time, and it's a complex balance of all of these different parameters. So I guess calculating temperature for the Earth, you have to have measurements of a lot of these things. Yeah. To then feed them into, and I guess it's an equilibrium equation.
Yeah, I mean, that's kind of a really cool way of thinking about it, and not something that my brain jumped to at all. If you were allowed to know what the temperature was at some point in time in the past, you could make a rough estimate of like an initial condition and then go that way.
Yeah, and this is essentially how climate modelling works, like how we predict, okay, with this amount of CO2 being emitted into the atmosphere, because we know the temperature now and we've known the temperature in the past, we can make an estimate for how much energy is being emitted by the Earth at the minute. How will more CO2 trapping more heat affect that to then predict what temperature will be in the future? I guess I maybe should have formulated the question as how would you go about calculating a temperature in 10 years from now for the Earth, for example.
That's kind of cool.
You need an input parameter. Knowing absolutely nothing about the temperature doesn't overly help.
But it's kind of a fun problem of like, if you pretend like it's a stationary system, so there's no time dependence and there's just frozen in time right now, but you had all of the measurements except the temperature. You could get something reasonable out of that.
I guess like that's probably a good place to leave things. I think the problem's been it's interesting to go into a problem and like divert into wherever the discussion takes us. If listeners or viewers on YouTube, I guess, have any suggestions for problems or topics we could go into in a segment like this, or topics to discuss on the podcast in future, send us emails. That's unstablefluidpodcast@gmail.com. Get in touch with us on our various social media. We are at unstablefluid on the social network formerly known as Twitter, and then on YouTube and Instagram we are at unstablefluidpodcast. If you're watching on YouTube, you can leave things in the comment section below. Put it in one of these places and we will probably see it, or I will probably see it.
Or scream it into the void and we won't. That works too.
Carrier pigeon would be an interesting method.
Yeah, we don't have a postal address though, so good luck with that.
Yeah, we don't.
But yeah, hopefully you enjoyed listening. We enjoyed rambling, so that's all that matters.
Thank you all for watching, and we'll see you, or you'll see us or hear us, you know what I mean, in the next episode.
Be perceived in the next one.
Thank you for tuning in to the second episode of the Unstable Fluid podcast. If you've been listening to us on a podcasting app, then please make sure to follow. If you're watching us on YouTube, then subscribe and hit the bell icon so you don't miss future episodes. If you'd like to get in touch with us, then make sure to follow us on Instagram at Unstable Fluid Podcast and at Unstable Fluid on the social network formerly known as Twitter. If you'd like to email us directly, we can be reached at unstablefluidpodcast@gmail.com. We'll see you in the next episode.